I am Keith Bashirs, and this is a report on artificial intelligence for the Management Information Systems class at Northwest Nazarene University, Master of Business Administration. What we call artificial intelligence is often a bucket for automated functions we don't know how to do yet. No longer in the realm of science fiction, these technologies are rapidly coalescing to make predictive judgment calls by information systems a viable capability. AI and AI-like functionality will significantly impact roles in many work settings in the next few years. AI is an approach which allows information systems to make decisions on behalf of humans. Not only does AI change the way work is done, it has very significant ethical implications, as the temptation to accept the computer's output as right can easily lead people to abdicating their obligation to act with morality. When making a judgment call, humans use intuition and their own moral sense to evaluate whether their decision is just. When there is no clearly correct answer, checking computer-generated recommendations becomes increasingly problematic. Artificial intelligence, AI, is a combination of technologies and managerial approach which allows certain decisions to be delegated from humans to an information system. The fundamental difference between data processing and AI is the degree of structure in the decision-making process. Data processing uses straightforward rules to generate consistent and predictable results from structured data inputs. AI is more tolerant of unstructured and random inputs, using predictive models to generate results which are probably, but not necessarily correct. In necessary but not sufficient, the protagonist is challenged to evaluate a computer output, which is described by the programmer as the best possible outcome, but without any clearly defined criteria to confirm or deny that claim. Traditional software systems operate on a simple but robust if-then-else network framework. Common business-oriented language, COBOL, literally uses this syntax. The data processing era was defined and constrained by the need to have predefined and predictable data inputs with highly structured outputs. Within that constraint, data processing can greatly reduce human effort needed to perform a wide range of repetitive tasks. But the software typically does not have an ability to critically evaluate the validity of the task. Early industrial robots could perform repetitive motions, but had limited ability to assess whether those motions were the right thing to do. The software's interaction with the outside world was limited to whether it was safe to perform the action and whether conditions were ready. An example from manufacturing, a welding robot would have some sensors to determine whether humans or other obstacles were in the path of movement and could sense when an object to be welded was in place with sufficient welding supplies on hand to perform the task. Whether the object being welded would become a car, a computer cabinet, medical device, or toy was beyond the scope of the controlling software. More significantly, what object to manufacture is totally beyond the purview of the computers managing the operation. An example of the difference between machine and human behavior from classic science fiction is a short story by Isaac Asimov, where human operators of a power station go into isolation because of a hazardous condition, leaving the automated systems unmonitored for some period of time. At the end of the life hazard, the humans return to the control center expecting at least some parameters to be out of tolerance. Instead, the reporting system, described as robots in the story, informed the humans that all metrics were continuously assessed and necessary adjustments were made in real time. There's no assessment of whether it was the right thing to do. The robots just do what they're supposed to do. The AI is able to adjust to unpredictable circumstances even better than the humans expected, but without any assessment of whether they should continue to do that task. They just do that task. In aviation, fly-by-wire systems continually detect changes in the flight path and adjust the flight controls as necessary to maintain adjust the flight controls as needed to make the aircraft do what the system thinks the pilot wants to happen. Boeing and Airbus have different fundamental approaches to the design of fly-by-wire. Boeing assumes that the pilot is in control and is making the correct decisions. The system is designed to perform tasks dictated by the flight crew unless the command is obviously wrong. Airbus assumes the pilot is an overseer. The system is designed to fly the aircraft within the parameters set by the flight crew and will override pilot input if that pilot input would put the aircraft at risk. Presently, problems with potentially thousands of parameters and highly unstructured data input can be automated. The Internet of Things enables sensors on geographically distributed equipment to gather data which can be correlated to make predictive recommendations with fleet or industry-wide implications. An example is vibration sensor data from self-driving dump trucks originally was installed to detect maintenance issues on the vehicle itself, but the evaluators were able to see a pattern which enabled detection and early repair of roads in the quarry. Global Positioning System, or commonly called GPS, enabled navigation systems on literally every smartphone and mobile device that in use is an AI-like capability. A simple internet search generates a recommended destination, and the navigation software predicts the most efficient automobile route in terms of both time and mileage. Coupled with an online ordering system, this capability results in the dynamic matching of drivers with restaurants and customers who want home delivery of takeout from a variety of cuisines. However, there are some significant potential problems with adopting AI. The examples from science fiction and aviation highlight implications for implementation and management of automated decision-making in other fields as well. Automated controls are very capable of keeping a system in balance. Even incredibly complex systems with vicious cycle reinforcing feedback loops can have limits imposed by AI-enabled controls. Initially, natural human skepticism will cause users to question the outputs enough to allow some intuitive application of general intelligence. However, as the results from automated analysis demonstrate sufficiently acceptable results over time, humans will naturally tend to accept the results at face value. This imposes a risk on the user, the organization, and those who depend on that organization, which is going to be caused by the law of unintended consequences. The likelihood of biases or defaults in seemingly minor subroutines or modules of the AI system could result in results being skewed in particular ways. To use another example from science fiction, the submarine's silent drive on the fictitious Red October was detected by a sonar operator who realized the software would flag as a marine mammal anything that it could not otherwise classify. Certainly, what we call AI frees people from the most tedious and process-oriented of analytical tasks. Artificial intelligence can sort and grade agricultural products and improve asset visibility and process management in industries as diverse as manufacturing and government services. Individual knowledge workers can use AI to gain better understanding earlier of even the most complex and random data. AI has the potential to greatly improve both the speed and quality of data analysis in every industry. AI has macro applications. What are the likely results to the economy of a particular political action? What does the climate data tell us to expect 100 years from now under various scenarios? AI also has micro applications. What is the buying behavior of a particular retail customer? What are the inefficiencies in a particular production process? Predictive and analytics, enabled by AI, move business intelligence from a mental exercise in educated guesswork to an increasingly precise and effective process. Rather than using data to do what businesses have always done, just do it better, these analytical tools allow implementations in the next decade which are only imagined now. Data is incredibly valuable to a company, but only if that data can be accessed, correlated, and applied to decision making. The cost of collecting, storing, and analyzing data is increasingly smaller. Additionally, data can now be collected without specific human decision in both physical and virtual sensors. Aggregating that data permits organizations to make monetary decisions more rapidly and with greater assurance. But AI comes with significant risks. As AI penetration into every industry increases, the need for less skilled and inexperienced workers will decrease. The resulting displacement of employees across the economy is sure to have negative impacts. While some industries are facing a staff shortage, which automation can compensate for, the economy needs entry-level positions where people can learn valuable life and professional skills. What those operations will look like in an economy dominated by AI remains to be seen. Equally troubling is how the question of highly skilled workers will acquire the experience needed to develop intuition. One does not become highly skilled in a classroom. Formal training develops foundational capabilities. Experience teaches which skill to apply in a particular situation. An example of the role experience plays in the developing of decision-making skills comes from the training model for U.S. Army headquarters units. The U.S. Army has a formal decision-making process which is taught in schools and applied during training exercises by units commanded by colonels and generals. The captains, majors, and lieutenant colonels in those staff units are often frustrated when the commander makes a decision different from the staff recommendation. After multiple training cycles, the staff members start predicting what the commander will decide, even if they are not quite sure why the commander will go against their recommendation. As the staff officer gains more experience, that individual, he or she, suddenly has an epiphany and starts seeing the factors in the problem that previously did not seem quite so critical. This process of training the intuition creates lieutenant colonels who are ready to replace those colonels when those officers retire or are promoted to general. Ethical issues with artificial intelligence. All that leads us to, make sure the slide flips. All of that leads us to some ethical concerns. Every ethical concern which exists before AI or without AI still is in play with AI in the mix. The automation of data analysis and decision-making does not remove the human factor. Every decision and action necessarily impacts people. The moral obligation to preserve autonomy implies the need for automated decision-making to not remove the humanity of either the user or those affected by the user's decisions and actions. The AI developer has an obligation to build the system in ways that permit those affected by the decisions generated to have final say in their own behavior. Justice, non-injury, liberty, and manner are all moral obligations which could easily be superseded by an automated decision-making system. Equally significant, developers will inevitably incorporate their own biases into the decision criteria of an AI system. There is a high opportunity for compounding of rather than minimizing the impact from artificially discriminatory practices. Existing biases in the data sets used to establish the baseline against which AI is trained are certain to become a reinforcing feedback loop. We claim that God knows all things perfectly. This is certainly not the case for any individual or group of humans, or even for all of humankind collectively. There are vast gaps between what we understand and what we are able to accomplish. Similarly, the difference between the general intelligence of a human and what is currently possible with machine learning or AI is vast. However, there is a risk of assuming that the computer knows more than it does know. It may process large quantities of data and produce predictions which seem logical or even wise, but it was created by fallible humans and necessarily reflects the brokenness of mankind rather than the righteousness of an omniscient divine. The 3 laws of robotic proposed by Isaac Asimov specifically require the automated system to understand what a human is, that it is not human, and that it is less than human. Whether teaching those rules to an information system is necessary or even valuable remains to be seen. The current political rhetoric about the damage humans are doing to the environment certainly gives credence to the idea of the Overman culture, where the computer systems which manage the systems of a future society decided that genocide of the humans was the wisest option for ensuring planetary survival. Maybe these lessons from science fiction are words of caution against creating automated decision-making systems with too much autonomy. Society limits the freedom of each individual to minimize the risk of inadvertently harming others. It is probable that the decision-making or recommending systems must similarly be limited. Artificial intelligence, or AI, was once the stuff of science fiction. We now live in that future. And the future is bright, but not without significant ethical risk. Current technology provides the ability to create information systems which are able to analyze vast quantities of data from multiple sources and generate reasonable predictions. Where the boundary lies between AI and AI-like is probably immaterial. The fact is, AI-like systems already significantly affect the way work is done. The temptation to accept the computer's output as is can easily lead to people abdicating their obligations to act with morality. People can also induce bias, discriminatory, or otherwise unbalanced perspectives into the outcomes produced by an automated decision-making system, either deliberately or inadvertently. In both cases, blaming the computer for unethical choices and in inducing bias calls for caution and self-awareness on the part of the programmers and the managers. AI is a present reality. The potential risks identified by 20th century science fiction must be addressed. Automated decision-making systems are capable of making predictive judgment calls, but by their nature, there is no clearly one right answer in these cases. How do the humans monitor the system to ensure that the result is actually best or just in the particular case? Thank you for listening to my presentation on artificial intelligence and AI-like in the 21st century. Huh?